Kind of probably an unusual topic for this group, and it's something that I don't deal with a lot, but it's one of those, I brought it up at the last meeting. It is something that's coming more and more of a big deal, both internationally, nationally, and in the state. Methane emissions and just groups now are kind of independent of any government agency doing this type of monitoring. So I thought I'd bring it to you all just to let you know what's going on and kind of what the state is doing about it, because kind of it's what I'm doing about it, because I'm trying to keep tabs best I can on this, because it's one thing that it's because there's so many groups doing this type of work, it's very hard to keep an eye and kind of keep a pulse on what all these groups are doing, what they're looking for, and what they're kind of doing with the data. So anyway, to get into the presentation then, the agenda, first we'll talk about methane monitoring. What is methane monitoring? This kind of has the idea that you know what methane is. It's a kind of it's a gas, but it can do many things. Yes, it's a pollutant in certain standpoints, it's a waste in other standpoints, it's a useful fuel in other standpoints. And so it's a kind of a complicated gas depending on where it is and what it's functioning. It's either kind of good or bad depending on how you look at it. Then we'll look at the data usage. So for all this methane monitoring that's going on, how are people using the data that's coming from this? And then we'll look at, okay, with methane, like what do we expect to see in North Dakota? Do we have methane in North Dakota? Hint, yes, from many different things. Then we'll go into what methane sources have actually been kind of documented in the state and investigated and kind of the results of that, and then go into conclusions of it all. So methane monitoring, when we talk about methane monitoring, and this is mainly looking at North Dakota, but just even globally, there's kind of three different levels you can think of it as. You have kind of the ground level surveys where it's just like for me, when I go out and inspect well pads, I have a little gas camera where I can go out and look for gas leaks from storage tanks, wellheads, flares, whatever. And there's also a kind of upgrade from that. There's different groups. EPA has one of these where it's actually a vehicle mounted air analyzer that sucks in air, kind of speciates what's in it, and kind of tells you what's in there, so you can detect methane that way. Kind of once you get above that, then you kind of have your drones and your aerial stuff where they're flying over refineries, different industrial plants, and then even down to well pads. And EPA's done this with helicopters, for example, and then a lot of research groups will use aircraft. Sometimes they're using things like spectrometers where it's just measuring the light coming, bouncing off, but some will actually take samples of the gas or the air as they're flying through it, and kind of like the ground survey equipment actually speciate what's in the gas. But when you're thinking of a plume of gas, it's very hard when you're in a plane because this plume is three-dimensional. And so some of them will actually show the flight path they take, and you see this plane going because it's having to go down through the column to sample this gas plume. So it's, on one hand, aircraft can cover a larger area, but because this is three-dimensional, it will usually take a lot more time to do an aerial survey because this three-dimensional component to it all. And then the last one, and the main focus that we'll be looking at, because it's kind of easier to talk about, it's hours and hours for all these others where satellites are fairly new. There's not that much to talk about, is the satellite mounted equipment. And I include in this one instrument that's actually mounted on the International Space Station. So whether you consider the space station a satellite or not, but basically satellite mounted equipment where now you're getting a very broad coverage, but at least historically the resolution has been pretty poor. If you're trying to measure something all the way out from space, it's a lot harder than if you're just right down on the ground right next to it. And one thing when we talk about satellites, we have to talk, especially within the last 5 years, talking about the older satellites that are measuring methane or, trying to survey methane sources versus the new ones that, especially now, they're specifically built to only look at methane. Where if you look at many of the older satellites that are up there, they're launched for missions to record all kinds of different things. For example, the instrument that's on the International Space Station was designed and kind of launched for the purpose of looking at mineral dusts. And so trying to measure different mineral deposits around the world and like Saharan dust, that's crossing over the Atlantic Ocean, that kind of thing. It's just one, as researchers started digging the data, they found for that instrument, that's the EMIT instrument, that you could actually detect and kind of quantify methane emissions with it too. And so it's very much kind of older, low resolution satellites built for multiple purposes, where nowadays you're getting not just research groups, but kind of the environmental nonprofit groups launching specifically built satellites for methane detection. And that's kind of what spurred this whole presentation, because they're starting to look at more and more sources outside of, say the Permian Basin, where kind of everyone goes, to more sources out of the field, like up here in North Dakota. So just some of the groups and companies that are doing this type of satellite monitoring is groups like GHGSat, which is a commercial company out of Canada, that they will do this type of methane monitoring and then sell the data to kind of whoever wants it, usually companies that are trying to, look at their assets. And then Carbon Mapper is a nonprofit that does this methane monitoring, and they're a philanthropic group, so they release the data publicly and just kind of give it for people to do whatever they want with it. And then you have Prisma, Nmap, EMAP, Sentinel, Landsat. All those are more research scientific satellites that are just trying to do studies with the data. And so they're recording all this data and giving it to researchers to do, regional worldwide studies on methane and other pollutants. So with all this data and with all these people, different groups measuring and collecting the data, you also have all these different data portals for where you can get the data. Problem is, it's very hard to figure out, okay, from this satellite, where's the data going that I specifically want, and which of it's free, which of it do I have to pay for, which of it, can I get in a format I can use? It gets very, very complicated. So it's one thing to get the data. It's a whole another thing to get the data in a format you can use. So just a quick example of kind of a comparison of what this data looks like. So kind of a group that we've been working a lot with is Carbon Mapper, and we'll get into more of them later in the presentation. But one of the nice things is they pull in multiple data sources, and so it makes it really easy to kind of compare what these different data sources look like. And so you can't really tell by the images, but this is actually the same area through three different sources. So the one on the left is an aerial image of the area through one of their their gas sensors. The middle one is an older satellite, and the one on the far right is one from the newer satellites. So you can tell, like, aerial's the best. If you can get aerial, you're going to get the best resolution. But comparing the older satellites to the newer satellites, it's much better clarity, better resolution with these new satellites. And so kind of the instruments they're using, like the EMIT satellite on the space station's the one in the middle, and then one of the new specifically built methane satellites is the one on the right. And so when you're looking at these, this is supposed to be methane data. And I know, at least when I look at it, I can't really tell a darn thing. Like, so is this all methane? What is this? And one of the problems is, so these are all basically spectrometers. This is all data gathered from spectrometers. And so basically the light reflection from the sun bounces off, and like kind of the data that those spectrometers work, you're dealing with reflections. And so, not to get too deep in the science, but you can have a lot of things throwing up reflections that look like methane, but actually aren't. And so if you look like on the aerial, roads will pop up really well. That's not methane. That's just a road. And it's like, so this kind of bare soil. So different soil features, clouds, certain rooftops. I've got a picture for West Fargo, and there's something about one certain block of industrial shops that their roof is just incredibly reflective. So it looks like, at least from this, you have this giant rectangular block of methane coming off of this building. No, it's the roof. And so it's just very hard to just look at this raw data and be able to say, ah, that's a methane leak. Oh, or that's not. And so what you get is kind of this raw data from all these instruments, but then you have what I call the interpreters. You have all these different groups that'll take this data and apply either some AI logic, some algorithms or something, and then try to determine, okay, what of this is a methane leak? What of this is just a soil, a cloud, something else? And so some examples, and we'll go through these, is the UN has a big one. They call their ion methane, the International Methane Emissions Observatory. And then you have MethaneSat, which is one of the specifically built methane satellites that the Environmental Defense Fund funded and sent up into space. And spoiler alert, that thing went dead last July, so it's not getting any more data from that one. And then Carbon Mapper, as we talked about, they've got their satellite, which is called Tanager, and it's still recording data. It's still active. And then those commercial entities like GHGSat and a couple others. And so you kind of have to find where the data is, get the data, but then have something to actually process that data and give you a result that you can do something with. So getting into a few examples. So like this is, and what I like is these are all public, freely available data portals. So you can go to any of these and see this. And so that's kind of why I'm bringing up these ones. Like if you ever want to look at it, you can go to these and look. Kind of the problem is, and something as I've looked at all these, so this is the United States through the UN's Methane Observatory. And what they've got modeled here is all the methane hotspots that they have looked at, and they have some confidence in that, yes, there is a methane plume here. So if you look, there's a lot, out east in kind of Pennsylvania, where, okay, you have a lot of gas wells, you kind of expect that. You have a big blob over kind of the Permian, okay, I can kind of expect that. Look in North Dakota, there's nothing. So good job. We have no methane in the entire state, I guess. But luckily, one of the commercial companies, GHGSat, they published a paper just last December where they basically kind of took all the data they had collected for different clients over the years and kind of drilled down, like, what sources do they see? And one of the nice things is they published a map with all the sources where they had picked up methane. And I know it's kind of hard to see because I just grabbed this from the paper. Well, they have a whole lot of detections over North Dakota. And so you have kind of one group, the UN's thing, saying, oh, there's nothing in North Dakota. And then you have this commercial group that says, there's quite a few. And so you get this where it, for certain, the high profile areas, especially like the Permian, a lot of people have been there. There's a lot of data for, but when you come to North Dakota, there's just not much. And so it can be very hard to, figure out, do we have methane or not? And then if we do, is it an issue or not? And this really speaks to, like, what is this data for? And so for researchers that are trying to look at, like, the global kind of methane profile, where's methane going? Where is it coming from? What happens to it? That kind of thing. They want to know necessarily about, what's happening in North Dakota, but it's not a high priority. They're looking at the biggest sources. So like, the Gulf Coast, all the refineries down there, like they're looking at the biggest sources. If they can get stuff from North Dakota, sure, but it's not a priority. And then, for companies, they're looking at this data too because they want to know, is my pipeline leaking? Is my refinery, is there something going wrong? Before, there's, either a safety incident or someone like me, a regulator, shows up and says, hey, flares off. The companies are trying to look at this too, but they're only going to look at their stuff. They're, oh, wow. I think if I move the mouse every once in a while, it'll wake up.
On its own?
Oh, okay.
There we go.
I'll just move the mouse every once in a while. Yeah. So the companies kind of are looking at stuff, and they're looking at stuff in North Dakota. It's just they're only looking at their stuff, and they're not exactly going to share that with me. So it's like, I know that data exists, but it's not something. Oh no. One moment. All right.
Yeah, there you go.
Oh, no. Sharing study shop. Okay. Governments. But it's not showing up on my screen. Okay, hold on. Oh. So I'll just talk as I'm doing this. So governments also looking at this data, as we kind of already talked about. Let me just end the slideshow. Sharing. Okay. From current slide. If you haven't gotten that, technology is complicated. As I'm talking about all the satellite stuff, this showcases just how tough it can be. So anyway, governments, you get kind of the international ones. So both the UN, but European. If you ever deal with like oil companies, or especially like the midstream, downstream, they're always kind of worried about all the European EU regulations, where they're trying to kind of like figure out for all the gas that's being sent to Europe for whatever reason, like how much methane was released associated with it, because they have various different rules and partnerships to kind of limit the amount of methane. And so it's kind of like, okay, you're going to sell me this gas, tell me how much methane like leaked out in the process of getting this gas to me. Well, then the federal government has a program that launched last year to kind of track the most biggest sources of methane. And so something they call super emitters. And so the number here is 100 kilograms per hour of methane. And so doesn't really mean much to me, because for me, like for the state of North Dakota, any emissions, we don't really have a cutoff, but it's like, I don't care whether it's 100 kilograms or 10 kilograms. I want to know what it is. And then the state of California launched their own kind of methane program to use the data, and we'll talk about that one later too. So first, we'll talk about the methane super emitter program, and this is something I talked a lot with the folks I work with, because when the EPA wanted to do this, we commented heavily on it and how it was not the best idea, but EPA did it anyway. So I have some strong opinions of it, but I will refrain from digging too much into those. Let's just say it's kind of redundant, did not need to be done. But anyway, so the EPA super emitter program kind of was designed with the idea that for all these groups that are going out and doing this methane monitoring data, be it, commercial, environmental group, whoever, that they could then go take this data, send it to EPA. EPA would look at it, make a judgment call whether they believed it or not, and then the EPA would go and notify the company they thought was responsible, and then the company would have to investigate and respond back to EPA what they found. And so kind of the first kind of group to sign on to start sending data to EPA was Carbon Mapper, a group we'll talk about a little bit more, and that who we've worked with too. And so we know their data, has some validity to it. But when the super emitter program started launched and started going at the beginning of last year in January of 2025, it did not go smoothly. So basically, Carbon Mapper told EPA, we found these 7 plumes that we think is methane over these sources. Here's the data. And then EPA was supposed to notify the companies they thought had those assets. And so there was one at the Bakersfield refinery in California, which, based on the records, EPA never notified them. There was 2 Chevron wells, and it looks like that all worked. It looks like EPA notified them. Chevron investigated and didn't find anything. But the last 5, so out of the 7, the last 5 or 4 were wells belonging to California Resource Company. Probably the best way to kind of sum up how this whole super emitter program has gone is California Resource Company's response to EPA, which you don't have to read the whole thing. I'll pick out the highlights, but this is from their official response to these detections. The first big thing they say is, we were not notified by EPA of this. We learned this through external sources, which I assume someone must have just called them and be like, hey, do you know your sites are on this super emitter program thing? Either that, or they, may have tried to, just found it on their own. But basically, the mechanism there where EPA was supposed to notify this company did not work. And then the last part is something where California Resource Corporation is telling EPA, we tried to send all the data for our investigations and our follow-up, which is what we're supposed to do when we get notified, to you guys, and we could not do it. The system to actually take that data at EPA did not work. And so you have this kind of breakdown of kind of what should have been a basic system. Group finds methane data, sends it to EPA, EPA sends it to company sends back to EPA what they find. Shouldn't be that complicated, but for whatever reason, it did not work. And so that's one of the things, like, even if you have a system for collecting this data and interpreting it, like, sometimes it just doesn't work. So now, moving away from the kind of the federal side, getting to states, California, in kind of response to kind of unease with how EPA was handling it and just kind of wanting to have more control over the data themselves, California just said, and basically I was listening to a presentation they give, and excuse my language, but basically what the governor of California at the time said is, we're just going to launch our own damn satellite. So, and it's like, okay. And they have the money for it, apparently, because they have a cap and trade. I didn't know about this, but they have some type of cap and trade program for and I assume it's like carbon credits or something. And so they pulled 100 million out of that, and they funded kind of their own satellite through that. And that's actually the satellite that Carbon Mapper uses. So the kind of the same data we get from Carbon Mapper was partially funded by California through their kind of satellite program. So it's kind of interesting how, through California's frustration with EPA and other things, we're actually getting a bit of a benefit from it. But it's nice that, and again, this is a public website that you can go and look at. An interesting thing about what data California's gathered through their use of this satellite is that the majority of the sources they see in California are not the oil wells. It's not like the oil seep, the seeps on the coast or anything like that. It's the landfills, which, you think about it, like, makes sense. California, how many people are there? It's like, yeah, you have a lot of waste, and, that breaks down. That's something that's very nice. That if you go there, you can see, like, where are all these hotspots in the major cities, right over where their landfills are. So that's kind of what's going on in California and kind of other places. But so what would we expect to see in North Dakota? What methane sources are there that we know about or can quantify to some degree? So this comes from an EPA database that they've had running for a long time, and it's basically an inventory where they try to estimate what the methane emissions are from every state in the country and kind of break it down by industry. And so at the top is agriculture, which is probably not a big surprise because different soil management practices and bring up enteric fermentation. Anyone want to guess what enteric fermentation is? And burps. So gas coming out both ends for the cows. Next one is energy, so oil and gas and combustion sources. Um, Third is land use and land use changes, and this is basically whenever you're converting a large swath of land. So say you're destroying a wetland or making a wetland, you're kind of changing like the emissions, the carbon balance in that area. And so that's what the land use and land use changes covers. And last is waste. So looking at this from, just saying what should be in North Dakota, I kind of expect, most of the emissions should be from agriculture, second from energy, and then the last two, maybe here and there, landfill or whatever. However, what I'm not describing here is kind of what we in the regulatory world refer to as area sources and point sources. And so an area source is kind of a broad swath of land like a big wetland or a slough or something like that. A point source is usually just something like a pipe. And so is it a vent pipe? Is it an exhaust pipe? Something that you could actually stick a probe up into and get a reading off of kind of thing. And so when you're thinking of like a satellite trying to collect methane data, it's much harder for it to look at kind of a broad piece of land like a slough and be able to get a methane number. It's much easier for, say, a flare or something that's unlit and just venting out gas for methane to pinpoint, yes, I have a plume there. The concentration's different and there's less what I call kind of noise around something like that. And so what you really see is you don't see anything from agriculture. You really don't see anything from land use changes. Everything you're seeing is from energy or waste because that's where your point sources are. So it doesn't mean there's nothing from agriculture. It's just much harder for any of the sensors to pick that stuff up. So digging into the carbon mapper data, this is, again, another free data portal you can go to. And these are all the plots they have of both methane and CO2. So they monitor both those pollutants and map them. And I'll just real quick say, if you want to know what those three big dots in the center of the state are, that's our power plants. And not a big surprise that, yes, we have CO2 coming from the power plants. We already know that. So that's not a big surprise. Out west, you see a big kind of cluster of methane detections over basically the oil fields in McKenzie County and a little bit in the Williams County. Not a big surprise because we know that's where kind of the densest collection of wells and all that are. But do note there's nothing kind of once you get from McKenzie County down to Dunn County, the detections just shut off. So I guess there's no oil development around Kildare, no oil development, in Stark County. And then there's nothing really in the eastern side of the state till you hit Fargo. And so it's like, okay, I guess there's just no methane anywhere else. Well, now we have to get into the idea of coverage. So a nice thing that Carbon Mapper does is they also allow you to overlay where all the coverage in the state is. And so again, if you remember, they pull in data from multiple different sources. So they've got their aerial data, they have the emit data that's on the space station, and then they have their own satellite. And so the big squares are the International Space Station paths. And so that's the emit data. And then the kind of the narrower rectangles, that's the Tanager satellite paths. And then the really narrow kind of strips are the aerial paths that Carbon Mapper has taken. And so you can see a lot of places don't have any detections because you don't have any coverage for it. And so you can't really say there's no methane up there. It's just no one looked up there. And I will say, kudos to Grand Forks because there is a lot of coverage there, but there's no detection. So, there's certain areas that just because you have a lot more coverage doesn't necessarily mean you will find a methane detection eventually. So if you look at all these different potential detections, I should say, kind of how they break down is so far you have about 33, 34. 29 of them are oil and gas, and that's, upstream, midstream, all kind of different sources. And then 4 solid waste are coming from, it's got to be a landfill. There's really nothing else it could be. One of the things North Dakota has done is basically try to figure out who owns each of these sources, contacting them, and then getting kind of investigative feedback on what they find out. And so of all the investigations that have been done, it's about a 50-50 on A, was the company able to figure out what this methane might have been? And then B, was it something that was either an accident or something that's just part of normal operations? And kind of what I mean by it is, we'll get into an example here. So this is from the Tanager 1 satellite. Picture on the left is pretty easy to pick out that something's going on here. Company did an investigation. They figured out they had a flare malfunction, which, if you know how a flare works, they didn't specifically say what it was, but I would guess that it was unlit, that it was not combusting, that it was just venting out gas. And so you can kind of see that, you have this kind of trail going to the northwest where that's methane gas coming off of a well pad. Picture on the right, though, is very hard for me to say, is there anything there? But contact the company anyway, have them go look at it. What they found was one of the hatches on one of their storage tanks was left open. And what they kind of guessed and determined it to be is a third party had come to their well pad to make an oil buy, gauged and evaluated the oil in the tank, but then forgot to close the hatch after they were done. And so for who knows how long, probably a couple days or so, the oil in that tank was just off gassing methane and other gases, and it was going out to the atmosphere. So kind of highlight the gas plume a little better. And so you can see it's like, it's not, the picture on the left, I can kind of see, yeah, that's a methane plume of some type. But some of these methane plumes are very hard to distinguish and very hard to interpret. So looking back at kind of all the investigations we've done so far, you kind of have this 2 categories of methane sources from especially oil and gas. I mean, landfills, it's just a landfill. Stuff breaks down, you have methane emissions for it. For the oil and gas stuff, though, you can kind of break it down into what I call kind of the planned events and the unplanned events. And so for the planned events, you have just well pad commissioning. So when they bring a well pad online, there's a lot of moving parts. And so you do have some methane emissions generated through that. And it's legal, it's permitted, it's fine. It's just, you can detect that. Next one is just maintenance blowdowns. And so there's various pieces of equipment that are pressurized. When they got to do maintenance on it, they shut it off and they have to get that gas out of that system, because you don't want to be opening up a high pressure valve and, bad things happen. So they have to blow down all that equipment, get all that high pressure gas out of it. And so you can detect those methane gases as well. And last, kind of surprisingly, is pigging operations. And so what pigging operations are is basically when you have a pipeline, you either have to do some cleaning on it, or you're sending a device through to kind of check the integrity of the pipeline and make sure you don't have any corrosion buildup, various reasons that you want to kind of check on your pipeline. And so what they do is they send these devices called pigs, not an actual pig, don't worry. But basically, sometimes it's just a little ball of foam that they'll send through the pipeline to clean off any gunk that builds up. And so to get that pig into the pipeline and then to get it out when it's done, you have to depressurize a small section of pipe. And so that depressurization generates some gas and you can detect it. And then you have all the unplanned events. So things like flare malfunctions, hatches on tanks being left open, and just equipment malfunctions of different types. So what this all kind of leads to, and again in the conclusions, is there's a lot of data out there, but there's a very limited set of data that once you get it, once you interpret it, And once you can kind of follow up on it, not a whole lot is actually actionable that you can do anything about. You know, if you're looking at big global scales, low resolution data is probably fine. It's just you're not going to be able to fix a flare that's malfunctioning or get a hatch closed on a tank. The data is not good enough for that. But for the data we do have that is actionable, that is kind of high resolution enough to do something about, we have been able to fix some problems. So example, like the flare that was malfunctioning, the company was able to get it fixed. And when the satellite flew over that site, it was about a week later, the plume was gone. Like you can say like this, found this issue, satellite found it, communicated it to the company found an issue, company fixed it, and the problem is gone. But then you kind of have all these others that we don't know, if it was either regular maintenance events, that those are going to keep going because it's a maintenance event, but we have those permitted, and those kind of things are allowed. And I think of all this, kind of the nicest thing is that all the methane plume detections, and these are big, if you're seeing it from space, it's a big plume. It matches what we'd expect it to be. Landfills, oil and gas, the point sources we kind of expected we should have. So what's nice for me anyway is that I'm not worried there's something we're missing, that there's some industry or there's some, just environmental process that's releasing a whole bunch of methane that we don't know about. So, no methane, I'll say no unplanned methane plume is good, but at least it's from stuff that we're already looking at. So with that, I mean, I could spend hours on these topics more, but that's kind of how the limit of what I've got for this presentation. I do have a whole bunch of extra slides too for questions, but for now, just leave it up to you guys. What questions you got?
On the AI part of it, how does the AI come in?
Great question. I've asked certain like carbon mappers specifically because we use their data. And it's one of those, especially for the newer satellites, they don't really have enough data because you really, like for AI, you need to train it on a lot of data saying like, this is what a methane plume looks like. So Carbon Mapper has said they have algorithms to help out with that. But the idea eventually would be you'd have AI looking at pictures like this and be able to say, like, it's hard for the people online, but like if you look at these 2 pixels, maybe this isn't methane, but we'll look at these 2 pixels and they are methane. Right. And so it's one of those, to see what they're going to do with AI, how they're going to do. There's a lot of questions like and opportunities, because one thing that would be nice, I don't know how it would work, but say you have it where AI just automatically goes through, flags this stuff, and preps everything, where then all you need is just kind of at least probably some human oversight to say, yeah, this is legit, send a notification to the company.
Won't you also look at historical stuff?
Once you get enough. And that's a big thing, like right now, with this coverage that you've got, you may only have one data set, and it's like there's not enough there. But as you get more and more satellite passes, like Eastern McKenzie County, you now have a lot of data for, and you can chart to train AI and kind of get that level of, how precision, we'll say, where you can say like this, especially if it's from the same source, this is normal maintenance because you can log it. Like here's our pigging or pig launcher. We launch a pig, say every week from this, what that emission is look like, and that's planned. Ignore this, you don't have to worry about it. Where we'll say from this piece of equipment, we should never have methane from it. If you see, any methane from it, notify us. Because that'll be a real big thing of getting down. They're not false alarms. They are actual methane plumes, but it's not something people have to deal with if it's just regular maintenance. And so I think that would be a good thing to have AI do, or just some type of machine learning to be able to differentiate it. But it takes a lot more data. And so that's why it takes a lot more satellites. And this is kind of a bad thing where this is just a data set from a very small collection of sources. There's a lot more satellites out there, mainly from the commercial side. We don't have access to that data. That data isn't being sent into whatever AI algorithms or whatever that carbon mapper is using. And so it's like, okay, or the commercial company is going to come up with their own version, usage of AI to determine these methane plumes, which is better, which is worse, and then which one do I have access to? Because it's one of those like, back in my mind, okay, should North Dakota start buying some of this data? And it's like, it'd be nice to have, but keep in mind, these are just snapshots in time. And so do I buy all of eastern McKenzie County for a year? And so, like, what is the cost to that? Versus there's oil wells up in Bottineau County, there's oil wells down in Bowman. Do I buy that data? How just where do you limit? How do you scale it down? And so if AI can make that cheaper, can like leverage of scale, make it where that data is cheap enough that you can analyze basically the entire state, because that's really where I'm looking is coverage for the entire state. Can it break it down cheap enough that we can do something about it? So I don't know, but I'm hopeful that it does something.
Is it all spectral, or is there any type of other
Most
imagery that you can gauge?
from the satellites, because obviously you can't do air sampling with the satellites. It's almost all spectrometers. I mean, it's the cheapest, easiest technology to do. Because there's so many different satellites, there's probably a lot of other technologies out there, but the spectrometer, kind of hyperspectral stuff, is the main one that's being used.
Follow up on that. After there's summary of the resolution metrics, kind of starting, or their algorithms filtering atmospheric noise.
So I've talked to them how they do it. And so they've got a paper that kind of outlines the exact procedure of how they take the data in, how they analyze it, and kind of the steps they take. I don't know if they actually release, I don't think they actually like have the algorithm itself, because at least my conversations with them, this is the aerial stuff they did. The satellite is based on that same equipment, but they have to do a lot more kind of calibration, because they're taking basically an aerial type instrument and scaling it to space. And so I wouldn't even know, like, for the algorithm, how many stages of kind of iteration and changes they've made to it, because talking with them, and that's one of the things why they reached out to us to get our feedback on, is they need more data on how accurate this is. Because I will say, this group Carbon Mapper and other companies, they've done kind of trial runs in places where they know there's a leak, and been able to kind of calibrate based on that. For those that may know, Colorado, I think it's State University, has kind of a gas emission study group, and they call it METEC, where they actually have dummy well pads and with equipment on it that they've built. And it's more designed for kind of ground and aerial equipment to go and see, okay, we have this dummy wellhead, we have a pipe leading to it that we are going to run this leak rate of methane. Let's see if your instrument can pick it up, and see if the emission rate your instrument says matches what we know is the leak rate, because we're controlling the valve. So they've done that with their satellites over this facility, and the numbers have matched up pretty well. So we know there's been real world kind of calibration that this has worked. It's just, even though Colorado is closer to us than, say, Texas, there's still a lot of differences up here in North Dakota, like when we have snow and kind of the weather we get. So what exact algorithm they have, I don't know, but they've got a pretty good paper that breaks down like exactly how they go about this. Long-winded, but that's okay.
Seems to me that with all these different data sources and different that
it could be a little bit ambiguous. And so is there a industry-wide or some standard where this data is analyzed and cross-correlated and try to get some type of idea of how valid it is?
So for companies that do their own monitoring, it's very nice. There's a group out of Montana called Bridger Photonics, and they do a lot of this type of, they do aerial, and they do a lot of methane monitoring for companies. And I've had some companies where they said, well, this supposed plume, we had Bridger Photonics fly our stuff the week later and didn't find anything. And so it's one of those, a lot of these companies are doing their own studies and their own work to be able to, is this legit or not? And then if it is legit, is it something that we need to do something about? A, we have a leak or, something malfunctioning, or is it just a regular maintenance event? And so it's very hard, to try to get some type of standard or some type of industry led coalition on when you could have methane from all these different sources. For example, one we had where it looked like it was from this well pad, and I contacted the well pad company. They went, they looked, could not find anything. But then they mentioned, well, we do have this pig launcher that we don't own, but this pipeline company owns. Maybe check with them. And I checked with the pipeline company, and sure enough, they pigged their line twice, once at 133, the second at 136, and the satellite flew over at 139. And so it's like kind of, if the industry knew kind of what sources to analyze for and kind of knew what data to look at, I think there could be something there. But the sources can be so widespread. I mean, luckily in North Dakota, things are spread out enough. It's not that hard. But for the more congregated areas like Eastern McKenzie County, and especially like cities, I mean, if we get more data for Fargo, I expect to see more methane, plumes from Fargo at some point. It's going to be much harder to say, is this from oil and gas? Is this from this and that? And like, I don't know if, any one industry would be willing to pony up just coverage for all their stuff. I mean, they'll be willing to pay for data on their stuff, but trying to get everyone else's, I don't know if they'd be into that or not.
So there's no standardized examination of all the different data sources, all the different data collectors.
Right, because it's all different instruments and they're all different resolutions, and so and that's why it's like it's really hard to say like what's the best. Is the commercial GHG sat stuff better than carbon mappers? I don't know because I haven't bought the data.
And we're collecting this data and regulating it based on a supposition that it is a climate affecting gas.
Well, I'd say more, and
I can see how industry would use it to cite their locations of problems and
yeah.
Get a pipeline or a pig launch or whatever. But isn't a lot of the basis of the regulatory effort based on the fact that this is a potent greenhouse gas?
Well, it's more, from, especially for North Dakota, kind of the rules we have, we say you can't emit any organic compound into the atmosphere without some type of control, unless it's via an emergency. And so while we do have some rules that kind of regulate methane to this degree, it's more like right now what we're treating this data is just a citizen complaint. And so, because we can't, because some of this is days, weeks, months after the fact, we have no idea if it actually is a methane plume or not, or if it's actually from the source that the cloud is over at the time. Like, for example, the pig launcher next to the well pad, it was over the well pad when they visualized it, but it came from this pig launcher, a separate company, separate piece of equipment. And so trying to determine whose plume it is, and then is it actually a problem? It's like not trying to get into the regulatory side of it at all, just treating it as kind of a citizen complaint. We got this complaint, go look, see if there's anything to it. And not yet. And it's one of those, maybe if we get more data, we'll see that. But again, it's kind of that would be an area source. And I think yeah. But unless it was a really point source kind of thing, probably not going to see it unless people do like a ground survey or an aerial survey of that.
Can we then suppose that natural phenomenon where you have biodegradation of organic matter, although it's not a point source, a significant amount of methane is outgassed just because we're on the planet.
Yeah.
The natural cycle.
And we know like with the kind of the emission inventory that EPA has, like soil management, like cows, you get a big herd of cows, a big manure pile, that kind of thing. That's just a natural process.
15,000 in the feedlot.
Right. You're going to have a lot of methane from that. And that's just a normal process of you have animals, you have waste. And it's kind of like for our landfills, it's like, I'll just pass forward real quick to one of the slides I've got. So the waste that's generated here is going to this place right now. That's Bismarck's landfill. And so the idea that like, if you're going to have waste, you're going to have methane emissions. It's just, are you ever going to have enough in one area that you're going to be able to pick it up and have an algorithm say, yes, this is actually a methane plume. I don't know if you're going to ever get a source like that. Yeah.
Natural gas.
Yeah.
Okay. And so it's happening in non-point sources in huge volumes all over the planet.
Yeah.
Just that's the natural course of
I don't
events.
think they have the resolution to.
Right. You're not going to be able to.
We don't have the source.
Right.
But in altering, measuring and monitoring methane emissions in the grand scale of things, since the planet's huge, there's all kinds of plants out there doing all kinds of stuff. And we have a few point sources. What's the percentage of the total methane ejected into the atmosphere from human sources as opposed to methane that is natural background in a ginormous planet that is of such low density that we can't even monitor it? That's so, I mean, are we doing triple backflips here for 0.03%, 0.003% of the methane emitted on the planet? And the net effect on the planet's climate, although the methane that we can see and monitor may be a very small amount with negligible effect. So do we have an idea of what portion of the methane created from whatever sources is the man-made methane, and is it significant in the alteration of the planet's?
So when we talk about things like global warming, climate change, the methane carbon balance of the world, I will leave that up to researchers and philosophers and people that have more data than me. So whoever wants to chime in on that, they can chime in at a later time for however they want to. Kind of what I'm looking at is point sources that may mean something that they need to do something about. Because it's like, if you have, per our rules, you can't just emit methane into the air, both from a resource perspective, because that methane can be captured, and like especially now with companies spending a lot of money building natural gas power plants, we need that gas to run not just our homes, but all the data centers and other industries that we want to bring into the state. And I'll say one thing that came up through this is we had one of our operators send us a notification that they accidentally left a valve open on one of their natural gas lines, and over the course of 9 days, they vented out 37 million cubic feet of natural gas. And it's like, we can talk about, well, a little methane, what, here, there, whatever. 37 million cubic feet could have heated a lot of houses, could have run a lot of engines, could have done a lot of good industrial work. Instead, it's now just floating, you know, probably over the East Coast at this point. So it's one of those, is like the goal here is to understand what methane is in the state. And then is it something that we need to do about to capture, to utilize, and prevent just going into the atmosphere? And that's really where like a lot of this comes from, like for the rules and kind of the follow up that, you know, what is there? Is it something we need to do something about? You know, the maintenance stuff, it's maintenance. I don't need to do anything about that. But if your flare blew out or fell over or whatever, and now it's just fending out gas, you got to fix that. And that's kind of all the focus that this is right now. You know, maybe once we get enough data on in 20 years, we'll be able to make some better science and kind of better judgment calls on. But right now, since the data is so limited, this is just kind of poking holes in dams, you know, keeping the methane where it needs to be. Good. Yeah. Yeah. So one of the big things is, so like this is a picture here, you know, oh, look at all those methane plumes. They're clouds. So, you know, soil types, you know, roofs, clouds, but snow, you know, because it's reflections, snow makes it very hard for these monitors to pick up anything. And I say for the past 3 or 4 weeks, Carbon Mapper hasn't told me of any detections, and I think it's because we're all so snow covered right now. You can, you know, again, that kind of brings into AI, where once the AI and the algorithms are smart enough, they may be able to pick it out, kind of the noise of snowy landscape, what is methane and what is just a reflection. But right now, snow is kind of a big challenge, and is also why it's very hard to get detections up north. And so, you know, kind of, and it was interesting that when GHG sat published their little paper with all their detections, you have a lot of detections up in like Canada and the northern, you know, Arctic of Russia. I don't know necessarily how they're able to get that with as much snow cover that they've got up there, but they were able to get it. So it is possible. It's just a lot more challenging. It's not as easy, which is why you have a lot more people working where there's not snow cover, like in Texas.
Since they're giving you,
At least for the ones that Carbon Mapper has given me, they have a regular visible light. I don't know what type of camera it is, but that takes the kind of the red, green, blue bands. And so you can then be able to say, okay, this is clouds. And for the most part, like any data around there, they just throw it out because it's corrupted by clouds. They don't use it. But there, you know, it's kind of like, well, okay, if you look at kind of the southern part of this image, there's really no clouds. You could probably still pick out some methane data there. And so there is some filtering that at least Carbon Mapper does, and I assume the other groups do as well, because it's clouds. I mean, you'd see it's a cloud, so you don't need to do any data. You can ignore that part of it.
research there, how often
Yeah.
are you getting coverage? What's the interval between the satellites on?
Great question. So right now it's kind of whenever we get it. Sometimes it's a weekly, sometimes it can go months, and we don't have any control of when it flies over or what areas it looks at. And so right now it's just, yeah, I don't know.
You're gonna know that it's something like that when you do get there.
Right. And it's like, okay, the data I do get, and that's why it's like you look at all these flyovers in the past that they've got, there is a lot of coverage in the state. It's just, especially for the EMET, because it's looking at such a broad data. If you look at a lot of those, it's all just clouds. And so you can't use it. So even if you have the coverage, it may not be good data. So, yeah, I mean, there's multiple challenges, and kind of why no one's done this till now, and no one's really been able to do stuff like over North Dakota. Right.
Some long-term trend.
You know, if it's something that happens every week, I can say that's probably just a regular thing that the, you know, facility does or whatever.
Months apart.
Right. was this, and it's a very, companies have come to me repeatedly saying, you got to get this to us quicker. And I'm like, I get it when I get it. It's like, because it's for them to follow up 6 months later. They don't know necessarily, did my employee blow down this compressor 6 months ago? Unless they have really good records, they're not going to know. And so they may not ever be able to follow up on what this thing is. And so it's very challenged. Is this something we need to worry about or not? I don't know. So hopefully as we get more and more data, we'll be able to answer that. So, okay.
Good questions, though.
Yep, thank you.